somebody at home is going to miss all of that knowledge. And I was about to say, am I messed up thetas? No proof. No proof it ever existed. All right, so let's say if we have our x and our y. Let's say if we go to this point here, where our radius is equal to 2, and our theta is pi over 3. So all we did was go out 2 and swing it up. Okay, so this is our r theta. Okay, or even, let's say if we have our x and our y, let's say instead we're going to swing our theta down that way. Okay, and let's say we call this one 3 negative pi over 6. Okay, so we go out 3 and swing it down. Well, it should be like that, but give or take. Swing it down negative pi over 6. Okay. Now, if we didn't want a negative pi over 6, we could easily rewrite it as 3 negative pi over 6 plus 2 pi. Okay, which would give us 3 negative pi over 6 plus 12 pi over 6. Okay, so we can always rewrite it as 3 11 pi over 6. Let me make that 11 a little bit better. Okay, oops, speed that up some. Okay, so you can rewrite it either way. All right, any questions on that one? All right. Okay. So next we're going to convert coordinate to Cartesian and Cartesian to coordinate, which really is not too bad. Oh, anyone's still writing? Leave that up for a little bit. All right. Okay, so coordinate conversion. Okay, so we know that sine of theta equals x over the radius. Cosine of theta equals y over the radius. Tangent theta equals sine over cosine, which is y over x. I swear this is not a good day for me and thetas. Okay. So that means if we multiply both sides by the radius, we have x equals r times sine of theta. Y equals r times cosine of theta. And tangent theta, we can actually leave it like that if we wanted to, since we don't really need it right now, but we will need it a little later. Oh, hold on. Nope, sine is... Nope, sine is y.
Opposite over hypotenuse. In this case...
Nope, sine is y. Why did I do that? Duh. I need to go home.
So why is it y over the radius and x over the radius?
Oh, because if you go to the unit circle, yeah. kind of thinking because it's the unit circle, but we're picking a point on the unit circle.
Very, very brave representation of the circle.
I know drawing a circle, but you kind of get the idea.
Sum of a circle's
Oh,
side
the
angles
radius
is
being
180.
the hypotenuse always.
Yep, exactly.
Okay.
Yeah.
Cool.
All right. See, I'll make me lose my train of thought again.
can
I'm easily distracted to begin with, so you.
So we can.
You know how much
square the circle.
talent it takes to say circle and draw triangle? That's a skill, I'm telling you. No
You need a
appreciation.
compass, man?
Is that why you keep saying, oh, no, I just blanked on it, the circle with the line through,
Theta.
theta?
Yeah.
So you keep saying theta but can't draw theta?
Yeah,
You just
that's
say
it.
circle but can't draw a circle?
Yeah, basically. It's a skill I honed over the years.
Do you need a compass, man?
Oh, that wouldn't help.
Okay.
I'd still draw a triangle. I know.
How did
Alright.
you draw a triangle? I don't
Okay,
know.
so we would use these to convert our polar coordinates to what we need our rectangular coordinates. Say to convert polar to rectangular, use y equals r sine of theta, and x equals r cosine of theta. Okay, so for example, let's say if we wanted to convert to rectangular, say problem A. Let's say if we have our r theta equals 2 comma pi. And let's say for B, our r theta is equal to, make that square root of 3 power over 6. Okay. So for A, remember that's your r, that's your theta. So x equals r cosine of theta would give us x equals 2 cosine of pi, which is 2 times -1. So I mean x equals -2. Y equals r sine of theta will give us y equals 2 times sine of pi. Okay, since sine of pi is 0, you get y equals 0. So the polar point 2 pi converts to -2, 0. I told you that one's pretty straightforward. Nothing really tricky about it. Okay, so let's say for B, our x is equal to our cosine of theta. Let me separate that a little bit. Okay, so that means that x is equal to square root of 3 cosine of power over 6, which becomes square root of 3 times square root of 3 over 2, which is 3 over 2. Okay, we do the same thing for y. Y equals r sine of theta. Means that y is equal to square root of 3 sine of pi over 6. Okay, so y equals square root of 3 times 1/2. So we know that y is equal to square root of 3 over 2. Clean that up a little. Okay, so that means that our polar coordinate square root of 3 pi over 6 converts to, we'll bring that up a little bit, 3 over 2 square root of 3 over 2. Might as well circle the final answer. All right. So any questions on that one? All right. Okay. So next we're going to convert it back. All right. Oh, forgot to put the formula for rectangular to coordinate. Okay, so we know that, let's say, cosine of theta, or x equals r sine of theta, y equals r cosine of theta, duh. Y equals r sine of theta. So we know that tangent of theta equals y over x. Apply tangent inverse to both sides. Know that theta equals the tangent inverse of y over x. We also know that our radius squared equals x squared plus y squared. If we go on our unit circle and have our right triangle. All right, so let's say, for example, if we have for the second quadrant, convert -1, 1 to a polar coordinate. Okay, now which quadrant is important because you need to know which one is negative and which one's positive, your negative x or positive x, or negative y or positive y. So you know if it's in the second quadrant, then you know your x is going to be negative and your y is going to be positive. Okay? But if you were in the fourth quadrant, your x would be positive and your y would be negative. So that's why they have to kind of tell you, because it makes a big difference on what your theta would be. I know you see me trying to figure out theta. All right, so let's say, breaking pencils again. For our solution, we know that tangent inverse of theta, remember that's our x and that's our y. Nope, tangent inverse of y over x equals theta. Going the other way around. Tangent inverse of y over x equals theta. Means that tangent inverse of -1 equals theta. So if it's in quadrant 2, theta equals 3 pi over 4. Okay, so we have our theta. We know that r squared equals x squared plus y squared. That means that r squared equals 1 squared, -1 squared, and 1 squared. So we know that r squared equals 2. So r equals positive negative square root of 2. You can't have a negative radius, so just square root of 2. Okay, so we know that negative 1, 1 converts to r theta, which is square root of 2, 3 pi over 4. All right, any questions on that one? Okay. Now you do have some that would be that you can actually solve without using this one. So let's say if you have, for example, convert 0, 2 to polar coordinate. Okay. So you can actually solve this one without plugging in a thing. Because if you think about it this way,
Move it up.
oh, sure, there you go. Okay, so we have our xy axis, and if we plot 0, 2, you can see that it's on the y-axis, which means theta is pi over 2. And it's a radius of 2, so just from that, you can figure out that it's, yep, your r theta is just equal to 2 pi over 2. Look, I swear these things, I've been breaking them like crazy all week. Okay, so sometimes if they're right on the x-axis or right on the y-axis, you can figure it out without really worrying about it. So if you wanted to convert, let's say, negative 3, 0, then you know your radius is 3 and your theta is pi. Going here just goes all the way around to pi, and your radius is 3. Yes?
If it follows, if it goes to the origin and is, let's say it's like y equals x,
Mhm.
right? Could you assume that it goes at the 45-degree angle?
Yep, so you would
Right.
think pi over 4.
Right.
Yep.
Okay.
And plus you could think for y equals x,
It'd be
sine would have to equal
square root of
cosine, which at pi over 4, they're both square root of 2.
2. Right.
So, yep,
So it'd
that's
be square root of 2 times, because isn't the, isn't one of the, like, special right triangles, 45, 45, 90, where
Yep.
both sides are equal and the hypotenuse is square root of 2 times that?
Yep, so you have 1, 1 square root of 2.
Would you use
Yeah.
that to find the radius?
Oh, not this is for, I don't want to think that's for the same problem. But for y equals x, I don't think you need it. You probably could make a use of it, but I don't think you need it. Let me see how, if you could.
Like, would you be able to use that identity at all? Like, I guess for the theta coordinate, but I don't know about the radius.
You might be able to. I mean, the radius would be equal, depending on how far you go out. So,
Yeah, plus, if it's just x squared plus y squared, you can just do that.
yeah,
Be fine with that.
yeah. So with that one, y equals x. Can you use that one? You might be able to, because especially since it depends on what your radius is, but eventually if you have a radius, it would have to stop. So if you know this is pi over 4 and this is 90, I guess you could figure it out that way, but it seems like it's kind of going a long way around. It's probably doable, but not really necessary kind of thing. All right. Any other questions on this one? All right. So